Today we're going to solve systems of equations with matrices. This helps us solve our system of equations much easier than doing it algebraic. We're going to look at this three-variable system we have here for starters. Notice that each equation is written in the standard form, which is ax plus by plus cz equals d. That is the form it needs to be in. All of your variables need to be on one side and your constants need to be on the other. It tells us that in matrix A times x equals b, A is a 3 by 3 matrix consisting of just the coefficients. So this first matrix A is our coefficients in the system of equations. The X matrix is a 3 by 1 matrix representing all of the variables. So we have X, Y, and Z. And then the final matrix B is a 3 by 1, and it is consisting of the constants. So our constants go in this last matrix here. Only the coefficients will go in this first matrix, only variables and only constants in that last matrix when you do the setup. All right, so we're going to look at setting one up here on this example. We said we have to have all of our variables on one side and our constants on the other, and that's not the case here. So that's going to be our first step, is to make sure that we get it that way. On our first equation, the 5z is on the other side, so we need to move it to this side of the equation. It's positive, so I'm going to subtract 5z to get it to the other side. That gives me 2x minus 4y minus 5z is equal to -1. I've moved the 5z over. In our second equation, we've got this negative x on the other side. So I am going to add x to get it to the other side. That gives me x plus 2y minus 3z is equal to 0, since nothing is left on the other side of the equal sign. The last equation's already in the standard form, so I'm just going to bring it over. Everything should be nice and lined up now. So we've got all of our coefficients on one side with the variables and our constants on the other side. Now, to set up that matrix, we're going to set up our coefficient matrix first. So I've got 2, -4, and -5. 1, 2, and -3. 3, -5, and -3. There's my first matrix. That's matrix A. My variable matrix will just be the x, y, and z. And then our constant matrix is going to be -1, 0, and 14. It's important to keep that organized. Notice that all of these are from one equation. All of these are from the next equation, and all of these are from the last one on the coefficients and constants. All right, we're going to move down here to see how we use that in order to solve our equation. We're going to start with a basic equation. Everybody knows how to solve 2/3 x equals 8. In order to do that, they're being multiplied, so we would multiply both sides of this equation times 3/2. That would get my 3's to cancel and my 2's to cancel, leaving the x by itself is equal to 24/2, which is 12. So we're able to solve. The reason why we did that right there is because it cancels our 2 and 3. And the reason why it does that is because that is the multiplicative inverse. So we multiply times the multiplicative inverse in order to get it to cancel out. With the matrices, that's the same thing we want to do. In order to get this A to the other side, we need to use the multiplicative inverse of this. Since we don't know how to do that, we can represent that with this little -1 on the top. That right there stands for the inverse. That will allow us to get x is equal to A to the inverse times B. So this is the inverse of A times B. And we did that with this little -1 here. That's what represents that -1. And that's what we're going to type into the calculator to get it to solve for us. So we're going to do a whole problem here just to make sure you can do that. This one already has everything in the standard form, so it's ready to set up as a matrix. We set up our coefficients. Our variables, and our constants. Now that we have that set up, we want to take this to the other side. Again, we do that with the a to the -1 power, so that's what we need to represent. So we're going to get 2, -1, -2, 3, 1, -2, -2, -1, 1. A little -1 shows the inverse of that, times our constant matrix, which is 3, 11, and -8. Now it's time to put in the calculator so that it does all the work for us. In order to put this in the calculator, we do alpha zoom, and we want a 3 by 3 to put in that first one. It has 3 rows and 3 columns. We're going to type that in, and you want to be really careful with the signs and making sure that everything is in there exactly the way it is on our paper. Even a single sign can throw the whole thing off. Now, to show the inverse button, once I have all of my coefficients in there, I want to hit this little button right here with the x to the -1 power. That's what's going to give me that inverse of the first one. Then we hit alpha zoom, and now we want a 3 by 1 matrix to put in our constants. And here I'm going to put in my 3, my 11, and my -8. Now I just make sure everything is correct. All of my signs are right. My numbers are correct. Yep. So I hit enter. There are my answers. So we had this x, y, z by itself on one side of the equation. And what's left on the other side now is 2, 3, and -1. That tells me that x is 2, y is 3, and z is -1. So if we wrote that as an ordered pair, it would look like this. X, y, and z. All right, I'll just go ahead and write that down. That is alpha zoom for the matrix menu. Then you're going to enter your 3 by 3. You can do this with the 2 variable systems as well. You would just do a 2 by 2 in that case. And then you use the button, the x to the -1, and then you do the alpha zoom again for the 3 by 1. And that solves the whole thing for you. It's a lot less work than actually doing it algebraically.